What are we trying to do? We're trying to find a Maclaurin series for the hyperbolic cosine of 3x centered at 0. That's because it's a Maclaurin. Then, what do we need? We need the hyperbolic cosines, e to the x minus e to the minus x divided by 2. Now what? The derivative of the cosine of x, hyperbolic, is, turns out, the hyperbolic sine of x. What's next? We need to find the derivative of our function, the hyperbolic cosine of 3x. So the first derivative of the hyperbolic cosine is the hyperbolic sine, and I use the chain rule. This is off the chain because I keep on keeping on. That's the hyperbolic cosine 3 squared. Then that's the hyperbolic sine 3 cubed. Then dot dot dot, and what? I evaluate that guy. So faux show, my function evaluated at 0, that's the hyperbolic cosine of 0. Guys, you guys are making so much noise on this thing. Okay, I put a 0 everywhere I saw an x, and 1 and 1 is a deuce divided by the deuce is a 1. Fun. Now, faux prime, that's going to be 0 for the same reason, because all of this guy, that's just freaking 0, because it's 1 minus 1 divided by 2. And then we do the same thing to the second derivative, and that's where we see that 3 deuce kick in. Then the third derivative, we see the 3 tray kick in, and then the fourth derivative, that's 3 4. All right, so now what? I write out my General Taylor. My General Taylor, that's my General Maclaurin, because I'm evaluating it at 0, and when I trot out all of those terms, I find that this guy is going to go to 0 and 0 and 0. And I see I'm left with my evens. So I had 3 to the O, 3 to the deuce, x to the deuce, 2 factorial plus 3 to the 4, x to the 4, 4 factorial. I find my general guy right there. But you're like in the book, they give us this formula for the hyperbolic cosine. They give the series there. So if I replace my x's here, then I also replace my x's there. And then I just do a little bit of algebra. And I'm done. Either way, it is the same thing.